Let's wrap up our review of factoring with some special factoring cases. We've got some formula for difference of squares, where we have something squared being subtracted by something else squared, always factoring into a binomial pair, 1 plus 1 minus, of those roots. Sum and difference of cubes. Again, similar concept, it's a binomial where something is being cubed and either being added or subtracted to something else that is cubed. Always gives us a binomial trinomial pair, and we can condense this actually into one formula for both, where x cubed plus or minus y cubed always factors to give us the cube root of both of those terms with a matching sign of plus or minus, and then our trinomial will be the first term squared. Then we switch the sign. So if our polynomial was a sum of cubes, we would be subtracting here. If it was a difference of cubes, we would be adding. Then we multiply x and y. And then last but not least, we add y squared, the second term squared. And that's going to be our formula for sum and difference of cubes. Then for our special cases, we have a perfect square trinomial. The way we check a perfect square trinomial is we take the square root of the first and last term, giving us x and y. And if they double it and it gives us our middle term, then we know it's a perfect square trinomial. And it will factor to be those roots plus or minus matching the sign as a quantity squared. Here we have a difference of squares. That gives us two binomials. Square root of each of those, 1 plus, 1 minus. Trinomial here, perfect square trinomial. Let's check it. The square root of our first term times the square root of our second term. If we double it, that gives us 120, which means it's a perfect square trinomial. So it factors to be the roots that we had, matching sign, quantity squared. Same over here. We check the roots, 2m, 7n. If we multiply 2m by 7n and double it, we get 28nn. So it is a perfect square trinomial. We match the sign, quantity squared. Sum of cubes. Cube root, both terms, r plus 3. Then we can ignore this. We don't need it anymore. We will build the trinomial off of our binomial. First term squared minus the two terms multiplied together. Last term squared, r plus 3, r squared minus 3r plus 9. Here we have a difference of squares again. Square root of the first, square root of the second, 1 plus, 1 minus. Here we have a difference of cubes. Cube root of the first, match the sign, cube root of the second. First term squared, plus the product of the two, plus the second term squared. There's our difference of cubes. Looks like it should be a sum of cubes, but I can't cube root either of these. Notice we have a GCF. Once we factor that out, now we have our sum of cubes. We cube root the two terms, square the first, minus the product of the two, plus the square of the second. We have another GCF. We factor it out. We have our difference of squares. The square root of the first, the square root of the second, 1 plus, 1 minus. Difference of cubes, cube root of the first, cube root of the second, first term squared, plus the product of the two, plus the second term squared. Be very careful when you're squaring to make sure that you're squaring all factors within the term. We have something in the format of a perfect square trinomial. If we take the first and the last term, the square root of r plus 5 is squared is r plus 5. Square root of 9 is 3. If we were to take the product and double it, we get 6r plus 5, which is our middle term. So we know it's a perfect square trinomial. So we take the first square, we take the second square root, we match the sign, quantity squared. Then we can simplify this. I said match the sign, but I wrote a different sign. R plus 8 squared. Sum of cubes, cube root of the first, match the sign, cube root of the second, first term squared, minus the product of the two, plus the second term squared. Difference of squares, the square root of the first term, the square root of the second term, 1 plus, 1 minus. Simplify. Be careful with that distribution in the negative. Sum of cubes, square root of the first, plus square root of the second, first term squared, minus the product of the two, plus the second term squared. Difference of squares, first term square root, second term square root, 1 plus, 1 minus. Notice here we have another difference of squares. Square root of the first, square root of the second, 1 plus, 1 minus. We have 4 terms, which means we need to result to factor by grouping. If we look really closely at the pattern, we see within the first 3 terms, we have a perfect square trinomial. The square root of the first term times the square root of the second term times 2 gives us our middle term. So it factors m minus 4 squared. Bring down the p squared. Now we have a difference of squares. The square root of the first term, the square root of the second term, 1 plus, 1 minus, and then we just simplify it. Difference of cubes, first term, second term, square of the first term, multiply the 2, square the second term. We have a sum of cubes, cube root of the first term, cube root of the second term, first term squared, product of the 2, second term squared, simplify. Our binomial squared will be a perfect square trinomial. Distribute plus our t squared. And there's all of our special case examples.